Hello everyone, third secondary students, sociology and economics section, mathematics, exponential functions session 3. In session 1 and in session 2, we learned how to solve equations and inequations with exponential. Also, we learned how to find the limits and how to find the derivatives of the exponential functions. At the end of this session, you will be able to study the variations of exponential functions and plot the curve of exponential functions. Problem 1. Consider the function f defined over R as f of x equals 3 minus x plus 1 times e power minus x plus 1 and denote by C its representative curve in an orthonormal system OIJ. Part 1a. Determine limit as x tends to minus infinity of f of x and calculate f of minus 1. First, remember the rule which says limit as x tends to plus infinity of ex equals plus infinity. So, if we find the limit of f of x as x tends to minus infinity, we get 3 minus infinity times e power plus infinity. So e power plus infinity, the limit as x tends to plus infinity of ex equals plus infinity. So we get the 3 minus infinity times plus infinity, which is plus infinity. Calculate f of minus 1. f of minus 1 equals 3 minus 1 plus 1 e power 2 minus 1 plus 1 is 0, so f of minus 1 equals to 3. B. Determine limit as x tends to plus infinity of f of x and deduce an asymptote d to c. The function is f of x equals 3 minus x plus 1 e minus x plus 1. Also remember the rule which says limit as x tends to minus infinity of ex equals to 0. So, the limit as x tends to plus infinity of f of x equal 3 minus, here we have a plus infinity, and here we have e power minus infinity, which is 0. So we get 3 minus infinity times 0. But infinity times 0 is indeterminate form. So let's solve this problem. We want to find limit as x tends to plus infinity of x plus 1 e power minus x plus 1. As we took in the previous session, we transfer the exponential from the numerator to the denominator and we change the sign of the exponent. Then we make Hospital's rule. Hospital's rule, first we find the derivative of the numerator, which is 1, and the derivative of the denominator. The derivative of the denominator is u prime e u, because e power x minus 1 has the form of e power u. So back to the limit, we get limit as x tends to plus infinity of 1 over e power x minus 1, which is 1 over plus infinity, which is 0. Then limit as x tends to plus infinity, don't forget the 3, equals to 3 minus 0, which is equal to 3. Okay, now deduce an asymptote d to c. We know that if the limit as x tends to plus infinity or minus infinity of a certain function equals to a number b, then y equals to b is a horizontal asymptote. Here we have limit as x tends to plus infinity of f of x equals to 3, then y equals to 3 is a horizontal asymptote at plus infinity. Part C, study according to the values of x the relative positions of C and D. When you want to find the relative positions between a curve and a line, or between two curves, we have 3 steps. First step, We subtract y of d from f of x. So we get minus x plus 1 e minus x plus 1, which is minus x minus 1 e minus x plus 1. Second step, we must study the sign of this difference. So we must study the sign of minus x minus 1 e power minus x plus 1. But don't forget, e power minus x plus 1 is always positive. So it is sufficient to study the sign of minus x minus 1 only. Now minus x minus 1, this is a linear function. So when we want to set the sign table, we use the rule of opposite, same, opposite of the coefficient of x, we get plus minus. Now, third step, when x is between minus infinity and minus 1, the curve is above d because here the answer is plus. Between minus 1 and plus infinity, the curve is below d because the answer is minus. Okay? And at minus 1, the curve and the line intersect at the point of abscissa minus 1 and ordinate 3. Why the ordinate is 3? Because the line D has the equation y equals to 3. Part 2a shows that f prime x equals x e minus x plus 1 and set up the table of variations of f. f of x equals 3 minus x plus 1 times e minus x plus 1. X plus 1 times e power minus x plus 1 has the form of u times v. So the derivative of f equals 0 minus u prime v plus v prime u, because the derivative of 3 is 0. Now u equals x plus 1, so u prime equals to 1, and v equals e power minus x plus 1, so the derivative is minus e minus x plus 1. Then the derivative equals minus e minus x plus 1 plus minus e minus x plus 1 times x plus 1. By a simple calculation, we get f prime x equals x e minus x plus 1. Now, we want to study the sign of this derivative. Also, don't forget that e power minus x plus 1 is always positive. So, the sign of the derivative depends on x. X is a linear function. The root of x is 0. Here we put opposite, same, okay? At 0, if we substitute 0 in the function, here we get f of 0 equal 3 minus 0 plus 1 times e power 0 plus 1, which is 3 minus e. And don't forget that the limit at minus infinity is plus infinity, and the limit as at plus infinity is 3. So the function decreases from plus infinity to 3 minus e, then increases from 3 minus e. F of 0 equals 3 minus e, which is approximately 0.281. Part B, draw C and D. When you want to draw the curve, you must use the data obtained in the previous parts. Note that the curve passes through the point minus 1, 3, and it is also the intersection between the curve and the horizontal asymptote y equals to 3. Referring to the table of variation, the point 0, 3 minus e is the minimum point. The function f decreases from plus infinity to 3 minus e. Then it increases to 3 where the curve has y equals to 3 a horizontal asymptote at plus infinity. Note that the curve is below the horizontal asymptote from -1 till plus infinity, and the curve is above the horizontal asymptote from -infinity till -1. Problem 2. Let f be the function defined on R as f of x equals x plus 2 minus 2ex. Let C be its representative curve in an orthonormal system, OIJ. 1. Part A. Determine limit as x tends to -infinity of f of x. Also, don't forget that limit as x tends to -infinity of ex equals to 0. So, the limit as x tends to -infinity of f of x equals -infinity plus 2 minus 2 times 0, which is -infinity. Show that the line D, y equals x plus 2, is an asymptote. This asymptote is oblique asymptote. How we prove a line is oblique asymptote? To prove a line y equal x plus 2 is an asymptote to C, we must, at -infinity, we must prove that limit as x tends to -infinity of f of x minus x plus 2 equals to 0. Limit as x tends to -infinity of f of x minus x plus 2 equal limit as x tends to -infinity of x plus 2 minus 2ex minus x plus 2, which is limit as x tends to -infinity of -2ex, which is 0. Part C, for all x in R, show that the curve C is below the line D. Here, as if we are studying the relative position between C and D, but here only we have one case, which is C below D. As we did before, we subtract y of D from f of x, we get minus 2ex. Now, what is the sign of minus 2ex? Minus 2ex is always negative, then the curve is always below the line D. Second part, determine limit as x tends to plus infinity of f of x and calculate f of 1.5. Limit as x tends to plus infinity of f of x equals limit as x tends to plus infinity of x plus 2 minus 2ex. Also remember the rule, limit as x tends to plus infinity of ex equals plus infinity, so we get plus infinity minus infinity, which is indeterminate form. As we took in session 2, in this case, we take a common factor. Here, we take x as a common factor, so we get limit as x tends to plus infinity of f of x equal limit as x tends to plus infinity of x into 1 plus 2 over x minus 2ex over x. Now, we have 5 basic rules that we took in session 2 on limits. One of these rules is limit as x tends to plus infinity of ex over x equals plus infinity. So we get here plus infinity onto 1 plus 2 over plus infinity minus 2 times plus infinity, which is minus infinity. Using calculator, we can find that f of 1.5 equals minus 5.4. Calculate f prime x and set up the table of variations of f. Now, the derivative of x is 1, the derivative of 2 is 0, and the derivative of ex is ex, so the derivative is 1 minus 2ex. Now we want to study the sign of this derivative. Here, as we took in session number 1, we want to study the sign of 1 minus 2ex. So first we suppose that 1 minus 2ex is positive. That is, ex is less than half. That is, ex less than e ln half. So x less than ln half. We set the table of variation. Why here we have plus? Because we suppose that the derivative is positive. We suppose that derivative is positive, and we get that x less than ln half. So, as if we are saying that the derivative is positive when x is less than ln half. So here the derivative is positive, and here the derivative is negative. F of ln 0.5, using a calculator, it is approximately 0.3. The function increases from minus infinity to 0.3, then decreases from 0.3 to minus infinity. Ln 0.5, using a calculator, it is approximately minus 0.69. Show that the equation f of x equals to 0 has in R exactly two roots, 0 and alpha. Verify that alpha is between minus 1.6 and minus 1.5. Don't forget, the first condition is that f must be continuous on R, which is true. Now, refer to the table of variation. First, on the interval minus infinity ln 0.5, this function increases from minus infinity to 0.3, which is positive. So the curve increases from minus infinity, that is, it was below the x-axis, to 0.3, which is above the x-axis. So the curve cuts the x-axis. Then the curve decreases from 0.3, which is positive above the x-axis, to minus infinity, so the curve cuts the x-axis at another point. Okay? Then the curve cuts the x-axis exactly at 2 points. So f of x equals to 0 has exactly two roots. Why 0 is one of these two roots? Simply we substitute 0 in the function, we get 2 minus 2e power 0, which is 0. We want to prove that the second root is between minus 1.6 and minus 1.5. We substitute f of minus 1.6 is negative, and f of minus 1.5, 0.05 approximately, it is positive. So the root alpha is between minus 1.6 and minus 1.5. Part 5, draw D and C. First we draw the oblique asymptote y equals x plus 2. Then we draw the points where the curve passes through. These points are the maximum point, which is approximately minus 0.69, 0.3. F of x equals to 0 has two roots. Then the curve cuts the x-axis at 2 points. The abscissas of these points are alpha and 0. Alpha is between minus 1.6 and minus 1.9. Also, the curve passes through 1.5 minus 5.4. Don't forget that the curve is always below its oblique asymptote D. Then the curve starts from minus infinity, where the curve has an oblique asymptote D. Look, the curve is below the oblique asymptote. It increases to 0.3, where it first cuts the x-axis at a point of abscissa alpha.
then it increases to the maximum point minus 0.69, 0.3, then it decreases and it cuts the x-axis another time at the point 0.00, then the curve decreases to minus infinity.
Dear students, what did we learn in this session? We learned how to use our knowledge in solving equations, inequations, derivatives, and limits in studying the variation and plotting the curve of some exponential functions. Thank you for listening. In session number 4, we want to solve a problem containing exponential functions with economical functions.